In this video, we will be discussing what fusion is, its history, and its potential uses and limitations as a clean and virtually limitless source of energy. So what is fusion? Fusion technology is the process of combining two atomic nuclei to form a heavier nucleus, releasing a tremendous amount of energy in the process. This is the same process that powers the sun and other stars. Fusion has the potential to be a virtually limitless source of clean energy because it uses hydrogen as fuel, which is abundant in the Earth's oceans. In fact, the fuel for a fusion reaction can be derived from seawater, which means we will never run out of it. In addition, fusion generates little to no greenhouse gases or other harmful pollutants, making it a much cleaner option compared to fossil fuels. The high temperatures and pressures required for fusion to occur can be achieved under very specific conditions. In order to initiate and sustain a fusion reaction, the hydrogen fuel must be heated to extremely high temperatures, around 100 million degrees Celsius. At these temperatures, the hydrogen atoms are stripped of their electrons, forming a plasma. In order to initiate and sustain a fusion reaction, the plasma must be confined and controlled. There are several approaches to achieving this, but the most common method is through magnetic confinement. This involves using powerful magnets to contain the plasma and keep it away from the walls of the containment vessel. The most well-known example of this approach is the tokamak, a donut-shaped device that uses magnetic fields to confine the plasma. Another approach is inertial confinement, which involves using lasers or particle beams to compress and heat the fuel, initiating a fusion reaction. This approach is being pursued at facilities such as the National Ignition Facility in the United States. The main challenge with fusion is that it requires extremely high temperatures to initiate and sustain a reaction. In order to achieve these temperatures, huge amounts of energy must be inputted into the system. The question then is whether it is possible to generate more energy from the fusion process than is needed to initiate and sustain it. This is known as achieving net energy gain, and it is the key to making fusion a practical and viable source of energy. The concept of using fusion as an energy source has been around for decades, but it was not until the mid-20th century that scientists began to make significant progress towards realizing this goal. The first successful fusion reactions were achieved in the 1950s and 60s by researchers at General Atomics in the United States, using a device called the tokamak. The tokamak is a donut-shaped device that uses magnetic fields to confine the plasma, a state of matter in which hydrogen atoms are stripped of their electrons and become ionized. Since then, many other fusion projects have been developed around the world, including the Joint European Torus, or JET, in the UK and the Princeton Plasma Physics Laboratory in the United States. These projects have made important contributions to our understanding of fusion and how to achieve it in a laboratory. In the early 21st century, the International Thermonuclear Experimental Reactor, or ITER, project was launched with the goal of demonstrating the feasibility of fusion energy. ITER is a collaboration between 35 countries and is currently under construction in the south of France. When completed, it will be the largest fusion device in the world, with the goal of achieving net energy gain for the first time. ITER is expected to begin operations in the 2030s. While significant progress has been made in the field of fusion, there are still many challenges to overcome before it can be realized as a practical energy source. Researchers must figure out how to initiate and sustain a fusion reaction for long periods of time, and how to do so efficiently and cost-effectively. There is also the challenge of developing materials that can withstand the extreme conditions of a fusion reaction. Despite these challenges, the potential benefits of fusion energy make it an exciting area of research that is worth pursuing. If successful, fusion could provide a virtually limitless and clean source of energy that could power our homes, businesses, and transportation for centuries to come. If fusion technology can be successfully developed, it has the potential to revolutionize the way we generate and use energy. It can provide a virtually limitless and clean source of energy that could power our homes, businesses, and transportation for centuries to come. Fusion reactions produce high-energy neutrons as a byproduct, which can be used in a variety of applications. One potential use in the production of medical isotopes, which are used in medical imaging and cancer treatment. Fusion reactions can produce a wide range of radioisotopes, including those that are currently in short supply or difficult to produce using other methods. Fusion could also have numerous other applications, such as propulsion for space travel. The high-energy neutrons produced by fusion reactions could be used to power spacecraft, potentially enabling long-duration missions to other planets or even other star systems. Future technology could also have other industrial implications, such as the production of materials or the treatment of waste. For example, fusion reactions could be used to transmute hazardous waste into less harmful substances or to produce new materials with unique properties. While the potential uses for fusion technology are numerous and exciting, it is important to remember that fusion is still in the development stage. There are many challenges to overcome before fusion can be realized as a practical energy source, and it will take some time and continued research and development to bring this incredible technology to fruition. While fusion technology has the potential to be a game-changing energy source, there are still many challenges to overcome before it can be realized as a practical energy source. One challenge is the issue of tritium, a radioactive isotope of hydrogen that is necessary for fusion reactions. Tritium is rare and expensive to produce, which could be a limitation for the commercialization of fusion energy. Researchers are working on ways to breed tritium from lithium, which is more abundant and easier to obtain, but this is a complex process that is still in the development stage. Another challenge is the issue of materials. The high temperature and radiation produced by a fusion reaction can be very damaging to materials, and researchers are working on developing new materials that can withstand these conditions. Developing materials that can withstand the extreme conditions of a fusion reaction is a complex and ongoing process that requires significant research and development. There is also the question of cost. Fusion energy is still in the development stage, and it remains to be seen whether it can be developed in a cost-effective manner. While the potential benefits of fusion energy are significant, it will take some time and resources to bring this technology to fruition, and it is important to ensure that it is developed in a sustainable and cost-effective way. Finally, there is the challenge of achieving net energy gain. In order to be practical and viable, fusion energy must generate more energy than is needed to initiate and sustain the reaction. While significant progress has been made in this area, researchers are still working on ways to achieve this goal efficiently and cost-effectively. Despite these challenges, the potential benefits of fusion energy make it an exciting area of research that is worth pursuing. Continued research and development will help to overcome these challenges and bring us closer to realizing the potential of fusion technology. Despite the challenges that remain, there have been promising developments in fusion technology in recent years. Researchers at the National Ignition Facility in the United States have come close to achieving net energy gain, and the ITER project is making progress towards its goal of demonstrating the feasibility of fusion energy. There are also several private companies such as Tri-Alpha Energy and General Fusion that are working on developing fusion energy. These companies are using different approaches such as plasma injectors and magnetized target fusion and are making progress toward achieving net energy gain. In addition, there have been a number of smaller scale fusion projects that have achieved significant milestones. For example, the Lockheed Martin Skunk Works team has developed a compact fusion device that they claim can be operational within a decade. Other companies such as Commonwealth Fusion Systems and TAE Technologies are also making progress toward developing fusion energy. While there is still much work to be done, these developments demonstrate that fusion technology is moving closer to becoming a practical and viable energy source. Continued research and development will be important in overcoming the remaining challenges and realizing the full potential of fusion technology. In conclusion, fusion technology has the potential to be a game-changing energy source that can provide a virtually limitless and clean source of energy. While there are still many challenges to overcome, continued research and development will bring us closer to realizing this incredible technology. If successful, fusion could revolutionize the way we generate and use energy, with numerous potential applications in fields such as medicine, space travel, and industry. It could also have a significant impact on the global energy landscape, providing a clean and virtually limitless source of energy that could help to address the challenges of climate change and energy security. However, it is important to remember that fusion technology is still in the developmental stage, and there are many challenges that must be overcome before it can be realized as a practical energy source. It will take time, funding, and the efforts of researchers and engineers around the world to bring this technology to fruition. Thank you for watching this video about fusion technology. I hope you have a better understanding of what fusion is, its history, and its potential uses and limitations as a clean and virtually limitless source of energy.